My dear friends, welcome to SEKAR classes on Applied Data Science with Python. This is lecture number 100. In this lecture, we will try to understand cumulative distribution function, mean, that is expected value, variance, standard deviation of discrete random variable. First, we will try to understand what is cumulative distribution function. It gives the probability that the random variable capital X is less than or equal to a certain number, that is capital F of X. Cumulative distribution function is represented by capital F of X and is defined as P capital X less than or equal to small x. Anyway, I will discuss in detail about this cumulative distribution function in my future classes. Time being, just understand that this capital F of X, that is cumulative distribution function, is always lies between 0 and 1. Expected value of X, that is E of X. Here let me say X is discrete random variable. If I say sigma, you must understand that it is discrete random variable. If it is continuous, I must say integration like this. But as it is discrete, I am saying it is sigma. E means expectation of capital X means discrete random variable, that is first expectation, also known as mu of X, that is mean of X, that is sigma X into P capital X, means random variable value into corresponding probability. That I must add them. I must collect all the values from discrete random variable. Anyway, we will try to understand with simple example. Here it is simple example. Just if you observe carefully, here X is a random variable, isn't it? Just see, this is capital X, let me say. This is P capital X equals small x, isn't it? You have random variable values. What are the random variable values here? Just understand the problem here. Data below, expected number of credit cards that customer to retail outlet will possess. Well, it's simple. Your X is, your capital X is credit cards. Capital X is 0. What can I say? Probability of a person having 0 credit card. Capital X equals 0 means a person having 0 credit card probability is 0.08. That is 0.08 means what? This is 8%, isn't it? Probability of a person have 6 credit cards. Probability, this is capital X, let me say. Probability of a person having 6 credit card is 1%. 0.0 means 1%, isn't it? The customers, now I must calculate average value or expected value. How can I calculate? This is a formula. E of X equal to, this is x1, x2, x3, x4, x5, x6, x7. This is P of x1, isn't it? P capital X equals small x1. Just I am multiplying them, isn't it? That's what we discussed. 0 into 0.8. This is x. This is x1. This is p1. Plus this is x2 into p2. 1 into 1.28. So on x3, p3. So on 6 into 0.01. You will get 1.97. What does it mean? The customers, they can have an average 1.97 can be corrected as 2, isn't it? The customers, they can have an average 2 credit cards. If you take any customer randomly, on an average, he can have 2 credit cards, isn't it? This is first expectation value, I can say mean or mu. Variance and standard deviation. Variance of X is denoted by V of X and is defined as sigma X minus mu whole square into P of X. Standard deviation is under square root of variance. This we discussed a lot in my previous lectures. We will try to understand with simple example. Here the quiz scores for particular students are given below, 22 to some 18. Find the variance and standard deviation. Which one is smallest number here? 12. How many times it is repeated? Only one time. Next smallest 18. How many times is it occurred? This 18 I have one time, second time. Therefore 18 two times. What about 20? First time, second time, third time, fourth time. 24 times. 22 one time. 24 two times. Just see 24. Where it is? This is 24. This is also 24. In that manner 25 is occurred 3 times, isn't it? Now mu is already given. If you want, you can calculate mu. It's not big issue. Variance of x is p1 into x1 minus mu whole square. P1 into what is my probability of 1? What is this? Is I can say frequency. Let me say here frequency definition. How can I say? Probability is relative frequency. I can say relative frequency was this is 1. Total how many are there? 1 plus 2 3, 3 plus 4 7, 7 plus 1 8, 8 plus 2 10 plus 3 13, 1 by 13, 2 by 13, something like that. Therefore, is it correct? 1 plus 2 3, 3 plus 4 7, 7 plus 1 8, 8 plus 2 10 10, 1 by 13. 1 by 13 is 0.08, 2 by 13 is 0.15, 4 by 13. Again this is 1 by 13. That you can calculate. You are getting probabilities x1. Just see here p1 0.08, x1 minus mu square. What is my x1? x1 is 12. 12 minus 21 whole square. 18 minus 12 minus 21 whole square. 18 minus 21 whole square. Why? Because your mu is 21. That you must understand. This is P1. I already calculated. This is P2. This is P3. P4. P5. P6. Isn't it? This is X1. X2. X3. Just 12, 18, 13. Just if you want, you can see it's 12. Just see 12, 18, 20. Like that. Isn't it? Just see. You can understand now. 12, 18, 20. Like that. Isn't it? Just it's a matter of substituting in formula. Therefore, what is your variance of X? It is simple and straightforward. Once if you get 13.25, sigma equal to under root of variance, under root of 13.25 is 3.64. That's simple and straightforward. Even if you want, you can calculate first expectation again. Same one more problem. This is x values. This is p of x values. How can I calculate mu or first expectation? X into p capital X equals minus 1 into 0.1 minus 0.1, 0 into 0.2, 0, 1 into 0.4, 0.4, 2 into 0.2, 0.4, 3 into 0.1. Just you must add all these things so that you will get sigma x into p capital X equal to x. That is essentially mu, isn't it? Now we calculated mu. How can I calculate this sigma square? Same, I have x, I have p of x. I know what is x minus mu. What is mu? Mu already we calculated. What is your mu? Mu is here, just see, mu is 1.0. Just remember, this is mu 1.0. Yes, 1.0 means what? I have here given values are x. I have x, p of x, x minus mu. Mu is 1, isn't it? Minus 1, minus 1, minus 2. Mu is 1. In previous slide we calculate 0 minus 1, minus 1. 1 minus 1, 0. 2 minus 1, 1. 3 minus 2, 1. You have got x minus mu. According to formula, sigma square is x minus mu whole square. This minus 2 square, minus 1 square, 0 square, 1 square, 2 square. This is x minus mu whole square. Sigma x minus mu whole square into p of x. What is my corresponding probabilities? This is x minus mu whole square into p of x means this is 4 into 1. That is the into p of x, isn't it? X minus mu whole square into p of x probability. Therefore, 1 into 0.2, 0.2 you are getting. 0 into 0.4, 1 into 0.2, 0.2. 4 into 0.1, 0.4. X minus mu whole square, this is your p of x. Just 4 into, this is, let me say 0.1, isn't it? Is it 0.1? Just check in previous slide. Yes, it's 0.1. Yes, as it is 0.1, here you have printing mistake. Just correct it as 0.1. Isn't it? It's small mistake. This is 0.1 actually. Now you will get x minus mu whole square into p of x. This is 1.2. That is sigma square. What is sigma? Under root of sigma square. Under root of 1.2. That is 1.10. Now you know how to calculate variance and standard deviation of discrete random variable. Just if you observe carefully, just understand this figure. Look at the picture A and B. Mean is same for both distributions. Is it correct? Are they having same mean? Yes, they are having same mean. This is mean. Here 6, Here also I have 6. Mean is same for both the distribution, but look at the variance. In the left figure, there is a lot of variance compared to right side figure. Variance means what? How much varied from mean? This much varied from mean. But whereas here variance is less. On right side distribution, you have less variance compared to left side distribution. Means even though they have got same mean, they have got different variance. Just observe this second case. What happens here? If you observe carefully, they have got same mean as I told you earlier. Just see, just this one is corresponding this one. But what about variance? Just see how much distance does it have from your mean. Same distance. Here you have 2. Here also I have 2. Just see distance. Here I have 8. Here also I have 8. Same distance. Means in this case, they have got same mean. They have got same mean. Even they have got same variance. They have got same variance. Isn't it? Just see 8, 2, 8, 2, 8. Even though they have got same mean and variance, but they are different distributions, isn't it? The probability distribution illustrated in part A and part B differ even though they have equal means and equal variances. The shape of the distributions are different. Just see, they are not the same distributions. This is something like this, but this is not like this. This is something like this. They have got different shapes of distributions. I will continue my discussion in lecture N101. Just go through this lecture. This is simple and straightforward. Thank you very much.